the tube of length A, L is shown in the figure. The radius of cross section at the point 1 is 2 cm and at the point 2 is 1 cm respectively. If the velocity of water entering at point 1 is 2 meter per second, then the velocity of water leaving the point 2 will be. So according to the continuity equation, the amount of mass of liquid entering per unit time at 1 will be equal to the mass of the liquid leaving at point 2. As the density is same, as the density of water is same throughout the pipe, so the volume will be same. So the volume per unit time, that is A, area times velocity, A into V, will be constant. So the volume entering per unit time at 1 is equal to volume of liquid leaving the point 2. So area A1 into velocity V1 is equal to area A2 and velocity V2 at point 2. We have to calculate the velocity of liquid at point 2, that is V2 is equal to A1 by A2 into V1. So here the velocity is V2, here the velocity is V1. And if radius at point 2 is R2 and at point 1 the radius is R1, then area at 1 is pi R1 square divided by pi R2 square into V1. Now pi cancels, R1 divided by R2, so R1 by R2 whole square into V1. Now put the value of R1 and R2. So the value of R1 is 2 centimeter, 2, and the value of R1 is 1 centimeter. Sorry, the value at point 1 is 2, yes, and the point at 2, that is R2 is 1 centimeter. So R2 is 1, yes, it is true. So R1 is 2 and R2 is 1, so 2 by 1 whole square into V1. V1 is the velocity at point 1, it is 2 meter per second, so 2. So 2 by 1 whole square, that is 4 into 2 is equal to 8 meter per second. So the water leaving at 8 meter per second from point 2. So option 4 is the correct answer. Thanks for watching. Please like this video, subscribe my channel and share